Very good morning, one and all. Today, we are going to see on the topic of what are the major components that we are going to use in the automation system, particularly for data analytics in automation system. So, my name is Karthi, and I'm working as an assistant professor in the Department of Mechatronics Engineering at SNS College of Technology. So, today we're going to explore the core building blocks that make the automated data analytics possible in the industrial and automation context. So, let's begin with a quick introduction that what is uh, data analytics and automation. That is, it is nothing but a simple systematic collection, processing, and analyzing of the data with minimal human intervention. That minimal human intervention may cause the major benefits, and important will be efficiency will be improved and the errors will be reduced, and we can get a real-time insights of what we are going to do with that application, and majorly with the most cost saving. So imagine a manufacturing plant where machines generate the data continuously and the system is automatically turns that raw data into an actionable insights without some manually intervening at every step. So why this is important? The benefits are more huge. That may be enhanced efficiency, reducing the error and real-time insights and significant cost saving. So you will see these applications in huge areas like manufacturing unit that may be in the predictive maintenance and healthcare by patient monitoring and finance area through cybersecurity and fraud detection and energy management, retail and even smart cities. So automation is transforming how industries is operated and followed by let's dive into the core components of the automation system. There are major there are major five backbone of the automation system in data analytics. That is data collection, data processing, data storage, data analysis, and data visualization. So these components works in a sequential pipeline, but they're highly integrated with each other. That may cause a seamless process from the data collection to the data visualization part. So this can be seen in the characteristics of data analytics, that is the five V's. So let's look into the first component, that is nothing but the data collection. So how we can able to collect the data? That is, this is the major foundation. Without the good data ingestion, everything will comes under failure process. So in automation system, data primarily comes from the sensors and IoT devices. So like a smart sensor embedded in machines, IoT gateways that aggregate the data, and a wireless network for the transmission. We also use a data acquisition system, that is DACOR, that includes analog to digital converters and signal processors to capture the signals accurately, and the followed by the key feature here is the real-time monitoring, that is continuous data streams with instant alerts if something goes wrong, like a temperature spike in a motor. Finally a modern system support with multi-source data integration, pulling data from the PLCs, SCADA systems, cameras, logs, and external sources into a unified stream. Without reliable collection, you'd have a garbage in and garbage out output devices. So in industry, this stage often involves the edge computing to pre-process data right at the sources. Moving on to the second component, that is the data processing. That is, the raw data is usually messy. So this stage is cleans and prepares it for the analysis part. So key activities including the data cleaning and validation is nothing but removing the errors, duplicate data, and missing values and inconsistencies in the data that we have collected. So then comes from the transformation and the normalization, converting the data into standard formats like scaling values or aggregating them. This classic workflow here is the extract from the sources, transformation as needed, and load into the storage. So in automation, we can gradually increasing the real-time processing with the tools like Apache Hadoop, Spark Streaming to get insights from the rather than getting from the batch processing overnight. This stage is more crucial because poor processing leads to inaccurate data analytics. So we have collected the data and we have processing the data where we can get able to get the followed by we have to storage the data. Once processed, the data needs to be safe and scalable form. So what we are going to here do is we can using the database management system like SQL for structured data and NoSQL for unstructured and or semi-structured data. So cloud storage solutions like such as AWS S3, Azure Blob or Google Cloud are popularly more flexibility. For analytics purpose, we have data warehouses like Snowflake or BigQuery for centralized optimized querying, and data lakes for storing massive amounts of raw data cheaply until needed. So don't forget the scalability and security system must scale elastically with data volume, and we need the encryption data access controls and compliances to protect sensitive industrial data. So now the exciting part is that the data analytics. This is where data turns into an intelligence. So we start with the statistical analysis, that is the descriptive stats, means trends and inferential, that is hypothesis testing. Then move to the machine learning algorithms, supervised for the prediction and unsupervised for clustering anomalies, and followed by the predictive analytics, that is a game changer in the automation. Forecasting the equipment failures, demand, or process outcome, we also do a pattern recognition to spot trends or anomalies automatically. So ultimately, this supports data-driven decision making. The system can even trigger automated actions like shutting down a faulty machine. So followed finally, the data visualization will come. So insights are useless if humans can't understand them quickly. So we built the interactive dashboards using tools like Tableau, Power BI, or Graphna user friendly interfaces with drill down capabilities. So real time monitoring means live updates and alerts on the dashboard. Common elements are charts and graphs, bar from comparisons, line for trends over time, pie for proportions. Automated reporting tools will generate daily or weekly insights, and the goal is data storytelling. Communicating complex findings clearly to the operator, managers, or executives. So, as you can see in the mind map, the integration is linear yet interconnected. That is data collection, followed by the processing, followed by the analysis, and followed by the visualization with feedback loops for continuous improvement. So, we came to a conclusion, and to the recap and the key takeaways, we have five core components that each will be more critical. The seamless data flows turns raw sensor data into an actionable insights. So a good system needs unified architecture for efficient communication and scalability. Looking ahead, the future is bright with deeper AI and machine learning integration, more advanced predictive capabilities, autonomous decision making, and self-optimization system. This will drive massive innovation across industries that will improve the efficiency, safety, and the profitability. So that's our session for today. We can see in our next class. Thank you.